Hey, welcome everybody. This video is for 7.1 in Algebra 2. And this is kind of the first unit of our second semester. And we're going to start off by reviewing factoring. So everything in this will be review of things that we did first semester, but are extremely important to what we're going to be doing second semester, especially with Chapter 7. So factoring is one of those topics that if you need help, I would highly encourage you to go see your teachers as soon as possible. So we're going to start off with examples 1a and 1b, where 1a is going to ask us to multiply two binomials. So what you want to remember is to distribute. Pause the video. I would try it on your own to make sure you get it, and then you can follow along from there. So we're going to start by distributing 3x. So 3x times 2x is going to give us 6x squared. 3x times negative 3 is going to give us negative 9x. Positive 5 times 2x is going to give us positive 10x. And then positive 5 times negative 3 is going to give us negative 15. Now, what you want to then look for is, are there any like terms that you can combine? And you should see that these middle terms are like terms. And when we combine those, we end up getting 6x squared plus x minus 15. All right, and that's how you multiply. Now, on the other side, 1b, we're asked to factor. So when factoring, we always want to look for a greatest common factor first. And between the 6x squared, the x, and the negative 15, there are no greatest common factors. So from there, anytime there's three terms, I'm thinking two binomials. Okay. And one thing you want to remember is that the terms that go here and here are going to multiply to give us this 6x squared. So we're going to think about the possibilities, which in this case are going to give us 6x and x and 3x and 2x. Now, the other pieces that are going to be important are this negative sign right here. This is going to tell us that we have different signs, meaning one is positive and one is negative. And then the last thing we're going to have to consider is the values that go here and here, they're going to have to multiply to this negative 15. Okay, and the fact that it's negative is why these signs need to be different. So what I would encourage you to do is list the possible factors of 15. So we've got 1 and 15. We've got 3 and 5. Now, we don't know which combination to use. And that's where we have to have kind of this guess and check approach, where do we start with 6x and x or 3x and 2x? And we're not always going to know. So we have to be willing to be persistent. All right, I'm going to go ahead and start with 3x and 2x. So 3x and 2x. Now, the thing to remember is whatever number goes here is going to get multiplied by the 3x. And then whatever number goes here is going to get multiplied by the 2x. When you combine those, it needs to give us the positive 1x. So if I tried 1 and 15, if the 1 was here and the 15 was here, well, 15 times 3 is 45. That's not going to work. And kind of if the 15 was here and the 1 was here, 15 times 2 is 30. Again, not going to work. So it leaves us with 3 and 5 for 3x and 2x. Now, because there was no greatest common factor, there will not be common factors here either. So if I'm going to use 3 and 5, the 3 would have to go here and the 5 would have to go here. Well, what you should notice from there is that when you multiply 3x times 3, you get 9x. And when you multiply the 5x times 2, you get 10x. Now, we talked about the signs being different. Well, if I take 10x and I subtract 9x, I will get the positive 1x that we need. So we want this to be negative, which means it's going to be negative here with positive here. Now, hopefully what you notice is that these factors, 3x plus 5 and 2x minus 3, are exactly what we started with in 1a. Those were the factors. This was the product. And that's because factoring and multiplying, or factoring and distributing, are opposite operations of each other. They will undo each other. So, kind of understanding that the outside and insides, when you multiply those, they combine to that middle term. it'll help you with this factoring process. All right, number 2. So it wants you to create a polynomial that has 3 unique factors. Now, you can pause this and try it on your own. But when I'm looking at this, 3 unique factors really means there are 3 different factors. Now, I could sit there and I could try to come up with polynomials and then factor them to see if they do in fact have 3 unique factors. But honestly, that's not going to be a very effective approach, because if we know that factors are unique, we can start with the factors and then multiply them like we did in 1a to come up with the polynomial. So for unique factors, I'm going to start with x as one of my factors. Another factor could be x plus 3, and then another factor could be x minus 4. Again, it really doesn't matter as long as you choose factors that are all different from each other. But this would be 3 different unique factors. And if we wanted to come up with a polynomial that has these factors, we can just multiply. So I'm going to leave the x alone, and I'm going to go ahead and multiply the x plus 3 and the x minus 4. So we're going to distribute x squared. This is going to give us negative 4x. This is going to give us positive 3x, which will combine to negative 1x. And then 3 times negative 4, that's negative 12. And then finally, if I distribute the x, we get x cubed minus x squared minus 12x. And because of the way that we did this, I can guarantee that this polynomial has 3 unique factors because we started with those factors. All right, number 3. It says now create a binomial. So think about what it means to be a binomial. Binomial is 2 terms. So we need an expression that contains 2 terms that's going to factor into a pair of conjugates. Now, remember, conjugates are where you have everything the same except the signs in the middle are different. So we talk about a plus b, a minus b. That's what conjugates look like. So one way to do this problem to guarantee that my binomial has 2 factors that are conjugates is to start with the factors, right? So if we start with the factors, we could say x plus 4, and then the other factor to be a conjugate is going to have to be x minus 4. Now, when we distribute that, we have x times x, which is x squared. We have x times negative 4, which is negative 4x. 4 times x, which is positive 4x. And then 4 times negative 4, which is negative 16. Now, you might look at this right now and say, well, there's 4 terms. But remember, we can combine like terms. So those are our like terms. This is going to be x squared. The negative 4x and the positive 4x are going to cancel. And then negative 16 is left. This polynomial does, in fact, have 2 terms. All right. So, that the idea of those problems is to just get you thinking about things that we've already learned this year, so that we can apply those in these upcoming lessons. So below is a table. These are the 6 types of factoring that we did first semester. All right, and we're going to just kind of go through an example of each just to remind you of the different forms that are out there. So the first type of factoring we ever learned, and we should always look for, is greatest common factor. So here I have 2x cubed minus 6x. So I'm going to look at this, and you should be able to realize that the greatest common factor is going to be 2x. And then in parentheses, I've got to find the other factor that when multiplied by 2x gives me 2x cubed minus 6x. So 2x times x squared is going to give us 2x cubed. And 2x times negative 3 is going to give us negative 6x. That is our GCF right there. And those would be the factors using GCF. All right. The next one is called the difference of squares. Now, we learned a formula And the formula for difference of squares said that if we have a perfect square minus a perfect square, it's going to factor into two terms that are conjugates, meaning one's plus, one's minus. The term in front is the square root of the first term, so in this case it's a and a. And the second term is the square root of the second term, which is b and b. So this type of factoring is directly related to that example 3 that we did above. So here, this is about recognition. I've got a perfect square, I'm subtracting a perfect square. So I'm going to start with two binomials. I know that one of them is plus, one of them is minus. X squared, the square root is x. And then for 25, the square root is 5. And that's how we factor. So x plus 5, x minus 5. I want to encourage you, really focus on identifying this form, because once you learn it, you can factor those pretty quickly. All right, the next one. Next type of factoring is a trinomial with a leading coefficient of 1. So in this example, all right, this is kind of very similar to what we did up here in 1b, only there's no number in front of x. So first thing we always look for is a GCF. We don't have one, so with 3 terms, we're going to go 2 binomials. The terms that go in front have to multiply to x squared, so x and x is the only way to get there. This negative sign right here is going to tell us that our signs have to be different. So we're going to have different signs. Now, because it's x and x, I can put a plus and I can put a minus. And then the last thing I'm looking for are 2 numbers that first multiply to 10. So it could be 1 and 10, it could be 2 and 5. But the other thing that has to happen with those terms is that when you multiply the outsides and the insides, they have to give you 3x. So if we use 1 and 10, there's no way we're going to get 3x. But if we use 2 and 5, if it's positive 5 and negative 2, this becomes 5x, this becomes negative 2x. Those will combine to give us the 3x. So that's how we're going to factor trinomials. And again, it's all about, following those steps, okay, one at a time. These have to multiply to this. These, they have to multiply to this. But the real key is that the outside and the insides got to give you that middle. And if you can learn it that way, it should start to make a little bit more sense. All right, next. This might be the hardest factoring we do, is a trinomial where there's a leading coefficient that's not 1. All right, so like any factoring, we want to check for a GCF, which in this problem, we do not have. So we're going to look at how many terms there are, which is 3. That tells us 2 binomials. The terms that go in front are going to have to multiply to this 3x squared. Well, the only options are 3x and x. All right, this time we got a negative again, which means different signs. Now in the previous example, I went ahead and put plus minus. But when the 3x and the x are different, the signs are the last thing I'm going to do. Now I know that they're different, all right, but I'm going to place them last because where I put the plus and where I put the minus is really going to matter. Now, the last terms I'm looking for are going to have to multiply to this 2, which the only option is 1 and 2. So if I put the 1 here and the 2 here, I've got to multiply to get this. So 2 times 3 is 6x, 1 times 1 is 1x. That's not going to work. But if I put the 2 here and the 1 here, 3x times 1 gives me 3x, 2 times x gives us 2x, which if the 3 is negative and the 2 is positive, I can get the negative 1x that I need. And these are the factors. All right, next we have factor by grouping. So when we factor by grouping, just like any other factoring, we always start by looking for a GCF. And when you start looking at the 4 terms, well, let me back up a second. The way that we're going to know to factor by grouping is because the problem has 4 terms. So that's something that you definitely need to be aware of, is when to use grouping. It's only if there's 4 terms. So we start by looking for a GCF, which we don't have. All right, 3 of the 4 have a like term, but not all 4. So when we group, we're going to start by grouping the first 2 terms and the last 2 terms, including the signs that are in front of them. Then for each group, we're going to take out the GCF. So for x cubed and 3x squared, the GCF is x squared. And then the other factor is going to be x plus 3. For the second group, the GCF is negative 3. And the other factor is going to be x plus 3. Now, for the grouping method to work, this factor has to be the same as this, and they are. And essentially what you're doing at this point is just using the GCF again, which is x plus 3, and then the x squared minus 3 is going to be the other factor. Because if we take out the x plus 3, we're left with x squared from here and negative 3 from here. And that's grouping. All right, last one is the sum and difference of cubes. Now, when this was taught, you learned a couple formulas. So with perfect cubes, it doesn't matter if it's plus or minus. So a cubed plus b cubed or a cubed minus b cubed. Those both will factor. And the way I always taught this was the signs go same sign, different, positive. So same sign, different, positive. And then what's going to go inside the binomial are the cube roots. So the cube root of a cubed is a, cube root of b cubed is b. So that's going to be true for both of those. And then when you fill in the trinomial, there's always 3 spots. The first blank is the a multiplied by itself. So a times a gives us a squared, and that's true in both. The middle term is a times b, so ab for both. And the last term is b times b, which is b squared for both. So that's the formula that we're going to follow. So when you see a problem like this, you've got x cubed plus 27. They're not perfect squares, but they are perfect cubes. So I always talked about, let's figure out what it is we are cubing to get those terms. All right, well, in order to get x cubed, we're cubing x. In order to get 27, we're cubing 3. So once we know that it's a sum or difference of cubes, all right, I've got a binomial and a trinomial. The signs are going to be same sign, different sign, positive. Now, the benefit of this step right here is whatever's in our parentheses goes here. Makes it real simple. And then you've got 3 terms. The first is x times x, so x squared. The middle is x times 3, so 3x. And the last is 3 times 3, so 9. All right. As that's basically a review of all the factoring we did first semester. So again, this is very important for second semester, chapter 7 in particular. So make sure if you guys need help, you see your teacher as soon as possible and get extra help, because factoring is going to be required in every single lesson that we do in the first part of chapter 7. So hope this was helpful. See you next time.